Workspace in Eclipse. Now we are focusing on Workspace. The various tools plugged into the Eclipse platform operate on regular files in the user's workspace. The workspace consists of one or more top-level projects where each project maps to a corresponding user-specified directory in the file system. The different projects in a workspace may map to different file system directories or drives, although by default all projects map to sibling subdirectories of a single workspace directory. Here you can see select a workspace dialog. As an example, we can consider this code segment. iWorkspace workspace equal resources plugin.get workspace. Interface iWorkspace. Workspaces are the basis for Eclipse platform resource management. There is only one workspace per running platform. All resources exist in the context of this workspace. iWorkspace is in package org.eclipse.core.resources. As an exception example, we can consider co-exception. If the method fails to copy some resources, the status contained in the exception may be multi-status, indicating where the individual failures occurred. Here we consider the exception which can occur in public iStatus copy iResources iPath destination boolean force iProgress monitor method in interface iWorkspace. And as an example too, we can consider workspace preferences. You can access workspace preferences from Eclipse menu, then window, then preferences. Now we are considering workspace in preferences. Refresh using native hooks or polling in options. If this option is turned on, then the workspace resources will be synchronized with their corresponding resources in the file system automatically using native refresh providers or on Windows or a polling mechanism. Note, this can be potentially be lengthy operation depending on the number of resources you have in your workspace. The default is off. Now we are considering switching workspaces in development environment. In references, the combo will also allow you to select your previously selected workspaces. The current workspace for Eclipse can be switched by using the file then switch workspace command. If you already switched your workspace previously, the previous workspace will be available for selection in switch workspace menu. The switch workspace, then other menu item will open the switch workspace dialog. The dialog will allow you to browse for or manually enter the new workspace location. The combo will also allow you to select your previously selected workspaces. Settings transfers. When you switch your workspace, you can select settings then will be transferred to the new workspace. These settings are supplied by the org.eclipse .ui.preference transfer extension. The SDK supplies transfer for workspace layout, opened views, their size, and selected perspectives, working sets, the user-defined working sets. Now we are considering batching resource changes, modifying the workspace. The code that manipulates the workspace is performed inside the run method. Void run iProgress monitor executes the runnable interface iWorkspace runnable. This interface is structurally equivalent to iCore runnable. The new code should use the iCore runnable instead of iWorkspace runnable. This is in the package org.eclipse.core.resources. When you need to modify resources in the workspace, it is important to keep in mind that other plugins might be working with the same resources. The Resources API provides robust mechanisms for keeping plugins informed about changes in the workspace and for making sure that the multiple plugins do not modify the same resource at the same time. Where possible, your plugin modification to the workspace should be batched in units of work inside workspace runnable. These runnables help to reduce the amount of change notifications generated by changes. They also allow you to declare which part of the workspace is to be modified so that the plugins can be locked out of changing the same part of the workspace. The protocol for iRunnable is very simple. A workspace runnable looks just like long-running operation or platform job. The actual work is done inside the run method with progress reported to the supplied iProgress monitor. Code that manipulates the workspace is performed inside the run method. When it is time to run the code, your plugins tell the workspace to run the code on its behalf. This way, the workspace can generate any necessary change events and ensure that no two plugins are modifying the same resource at the same time. Even if your plugins is not using background jobs and concurrently framework to modify the workspace, other plugins may be doing so. Do actual work in here. Now we are considering registering a listener in tracking resource changes. First you must register a resource change listener with the workspace. The interface iResource change listener. A resource change listener is notified of changes to resources in the workspace. These changes arise from the direct manipulation of resources or indirectly through a resynchronization with the local file system. This is in the package org.eclipse.core.resources. Your listener will be notified after modifications to the workspace resource have been made. Resource API methods that modify the resources trigger these events as part of their documented behavior. The method comment for the resource API method explicitly state whether or not it triggers a resource change event. For example, the following here included in the ifile.setContents comment. The methods that create, delete, and change a resource typically trigger these events. Methods that read but do not write resources typically do not trigger these events. Now we are focusing on MySpace jobs in concurrency and Workspace. The work is moved to the appropriate method of our Workspace job type here. The class Workspace job, a job that makes an atomic modification to the workspace. Client must implement an abstract method run in Workspace instead of use our usual job.run method. This is in the package org.eclipse.co.resources. A job is a basic unit of synchronous work running concurrently with other jobs. The resource plugin defines Workspace job as a convenient mechanism for defining asynchronous resource modifications. Code that would normally be batched in the iWorkspace runnable is instead put into the run in Workspace method of Workspace job subtype. Instead of running the code using iWorkspace protocol, the job is scheduled just like any other job. The appropriate scheduling rules must be added on the job before it is scheduled. Let's look at an example Workspace runnable and what we should do to make it a job. The work is moved to the appropriate method of our work job space to do the subtype. Our runnable had to invoke especially. Our job is scheduled like any other job. Platform job manager will run it accordingly its priority. Other jobs in the queue and the scheduled rules. Note that we must attach the scheduling rule to the job in order to prevent simultaneous modification of my project. Note that the operation had been structured as a job of all the scheduling mechanism. Priority delay rescheduling can be used. Resource changes event will be batched until the job is finished running. Do the actual work here. Do the actual work here. Now we are focusing on a sample resource tree in resources and the workspace. Each node other than the root is one of the three kind of resources, and each has a name that is different from its siblings. The tree below, represented in Workbench Navigator view, illustrate a typical hierarchy of resources in a workspace. The implied root of the tree is the workspace root. The projects are immediate children of the workspace root. Each node other than the root is one of the three kinds of resources, and each has a name that is different from its siblings. Resource names are arbitrary strings, almost they must be a legal file names. The platform itself does not dictate resource names, nor does it specify any names with special significance. One exception is that you cannot name a project project.metadata, since this name is used internally. Projects contain files and folders, but not other projects. Projects and folders are like directories in the file system. When you delete a project, you will be asked whether you want to delete all the files and folders it contains. Deleting a folder from a project will delete the folder and all of its children. Deleting a file analogs to deleting file in the file system. Now we are focusing on startup and shutdown workspaces in preferences. Prompt for the option prompt for workspace on startup. If this option is turned on, then the workbench will prompt you each time it is started for what workspace to use. The default is on. Now we are considering implementing a save participant. Let's look at a simple plugin which demonstrates the save process. To the interface iSave participant, a participant in the saving of the workspace. This is in the package org.eclipse.ucore.resources. To participate in workspace saving, you must add the save participant to the workspace. This is typically done during your plugin startup method. This is also where you read any state that you might save when your plugin was last shut down. Let's look at the simple plugin which demonstrates the save process. iSave participant defines a protocol for workspace save participant. Implementers of this interface can provide behavior of different stages of the save process. The plugin instance should read any important state from the file. Now we are considering package org.eclipse.emf.cdo.workspace concepts to check out, open, and further operate CDO workspaces. The package org.eclipse.emf.cdo.spi.workspace server provider interface SPI for CDO workspaces. Package org.eclipse.emf.cdo.transfer.spi.workspace client concept for dealing with transfers of resources between systems. For example, we can consider this situation in Eclipse Oxygen. Eclipse Oxygen stuck loading workspace. Now this is the end of my presentation. Thank you very much for watching it.